do in these first few minutes, I'm going to go slowly through the sine wave. Make sure that you have your ordered pairs correct. Make sure that you have your characteristics correct. Then I'm going to go much faster through the cosine. Okay? First things first, if I have an x, y table, what do my x values run through? From what to what?
0
to 2 pi. And I hit all the, what's the keyword? Quadrantals. Pi over 2, pi, 3 pi over 2, and 2 pi. My y values for sine start where? At 0, 0, right? Because sine at 0 degrees is 0 as an answer, as a y value. Then I consider this the middle. From 0, what does the sine wave do? It goes pi over 2 up to 1, then
middle,
0, then
down,
then
middle.
okay. So when we go to graph this, this starts at 0, runs to 2 pi. I like to refer to it as cutting in half and then cutting in half again. You'll hear me say that a couple times today. We're going to both go from 0, 0 to here, 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 and here. Here is this set of points. I'm going to typically have you go not only one full period, but 2. You can keep going in that direction. Usually I think it's easier to go back. So we're going to do the same thing. Go back 2 pi, cut in half, half, half. This was high, middle. Where's it going to go now? Low, middle, high, middle. There's my 2 periods of a sine wave. Now, when we go to list the characteristics, we start with domain. What's my domain?
Negative infinity to positive.
But I want you to add this phrase if you don't already have it. What do my values represent? I'm plugging what into x?
Everything.
You can plug in anything, that I agree with, but what do they represent?
Pi.
That's an example.
Every single
Radians, any type of angle. If you don't have that, I would add that. I'm substituting in angle values into, if you want to add this at the top, my sine of x. Now, what is my range, please?
negative 1 to 1.
Negative 1 to 1. That should make this easy. The min is?
Negative 1.
The max is. Okay. But now, we're going to add this. I didn't ask you to, but we're going to add it together. We're going to add the amplitude, the vertical shift, the phase shift, and the period. But before we list anything, we're also going to talk about words. So before we list amplitude, we want to remember what amplitude is. If you could explain amplitude, raise your hand. Go ahead, Phoebe, go.
From the well, not really the x-axis, but in this scenario, it's from the x-axis.
I consider it the
highest
middle.
Point. Okay, the middle to the highest or lowest point.
Yeah, for the middle to the high or the middle to the low. There's also a way to do it if you want to process. Do you remember what that is? I only said it once, I think. You can take the max minus the min and divide by 2, right? Because 1 minus negative 1 would be 2. 2 divided by 2 is the amplitude. What is the original amplitude here?
1.
It is 1. The distance from the middle of the y values to the max or the middle to the low is 1 unit. Now, from the original, it's almost silly, but is there a vertical shift? You would tell me no, because it's add or subtract. We consider that 0. Is there a phase shift? No, we would consider that 0. But here's what I felt like we didn't totally understand yesterday that we want to get cleared up. We need to list the original period, but we need to know what a period is. If you feel like you could explain what a period is, will you raise your hand? Oh, nice. Okay, Brendan, you want to try it?
Well, isn't it just the interval you go across the x-axis?
Yeah, kind of. We're going to say it like this, and you're going to repeat after me. We're going to say it's the amount of space you go through an entire cycle before it starts to repeat. Okay? I'm going to say it again, then you're going to repeat it. It's the amount of space you go through an entire cycle until you start to repeat. Ready? You're going to say it. It's the amount of space you go through an entire cycle
before it starts to repeat.
Yes. Now, typically what happens when we repeat is we want to do it together. Let's try it again. It's the amount of space you go through what? An entire cycle until when?
It starts to repeat.
So I think of this origin as the middle of the upswing. You see what I mean right there? When does the middle of an upswing occur again? 2 pi later. Does that help anybody? The amount of space you go through an entire cycle until you start to repeat. So what is the distance of the original period? It is 2 pi. Okay, we're going to move on to cosine. I'm going to go faster this time. You ready? All right. So for cosine, we have the same x values on the table. 0, pi over 2, pi, 3 pi over 2, and 2 pi. But this time cosine starts how? High. And it goes high,
Low.
middle, no, high, middle,
That's what I meant. It's
low, middle, high, right? So when I go to draw this, I'm 0 to 2 pi, cut in half, cut in half, cut in half. Then I start up at 1, middle, low, middle, high. There's a period. I want 2 periods, so I'm going to go back the other way. Me personally, you're welcome to go the other way as well. I start high, so going back this way also has to hit what next? Middle, low, middle, and high. There is my full 2 periods. My domain is still what?
0, negative infinity, nothing.
Okay, my range is what?
1, negative 1 to 1.
Which makes my minimum
Negative 1.
my max.
1.
Okay, but now we're going to list the other 4 main criteria. What is my original amplitude? 1. Do I have a vertical shift or a phase shift for the original?
No.
Kind of a cheesy question. What is my original period? 2 pi. All right, so now in your groups, we're about to do our first more challenge. Our goal in the last 15 minutes is to get through 2 problems. Okay, that's all we got to do.
Alright.
So we're going to start with cosine, but this time we're going to go like this: 3 cosine of x over 2 plus 1.
Wait, is this?
Now, these are not in your notes. So similar to yesterday, I want you to go to the back of your packet because I want you to have these as reference. Okay? These will really probably be the last 2 that you're just drawing from scratch. Okay? For the most part, I will give you graphs, but I find it super healthy to get in the habit of this. Okay, so you are not going to touch what's happening with the x's. Okay? I don't want you to touch that at all. But what you are going to do is use your parent graph and table to come up with the new y values. Do you feel like you could do that from yesterday? In your groups, please come up with the new y values. Go.
Wait, should we write out the parent to the potty really quick?
You have the parent ones on the front.
4,
Miss May,
1,
can I go to the potty?
Yeah.
0,
Where's your phone?
-1 times 3.
I have it back today, everyone. Probably not next week.
Would it be 4, 1, negative 2, 1, 4?
Yeah.
What are you doing? Dennis. Alright, so say
Times 3 plus 1 for the
it's
y.
0, it's 4, 1,
Yeah.
negative 2, 4, 1, negative 2. Dennis,
Yes.
say this is a political spectrum. Where would you be?
No, Jackson, no.
Wait, I'm just curious.
I know you are, but have that discussion a little bit. Not right now.
No, what are you
So, fine.
So we have
What
1.
about what about the
Yeah.
1 negative 2
4, 1, negative 2.
There's no changes.
No.
Yeah.
Because 1, 4 minus 1 is
Okay, if you've got your y values done, raise your hands. All right, so let's go. Tell me if you're fine just rattling off those y values because you're pretty sure they're right.
Oh, wait, no, you're right.
Okay, nice. Alex, go.
4, 1, negative 2, 1, 4.
Okay, so I want to show you a couple ways to be checking your work along the way. Okay, if you got that list, raise your hand. So I want you to notice a couple things. First of all, what is the distance between 4 and 1?
3.
And between 1 and negative 2?
3.
So what I love is, what should that value represent? The
Amplitude.
amplitude, right? Now, secondly, If I take the number 0 and have it undergo tripling, what happens to it?
No.
Nothing, right? So whatever 0 or wherever 0 was before, not only is only the shift, but it should match the vertical shift. Okay? Step 3 that I think most of you will like big picture is this. There's a process referred to as mapping notation. And I'm going to show you how to avoid this if you don't want to do it, but some of you will really like it. It's what literally happens to the parent points. And aren't you taking the y values, tripling them, and adding 1? It's essentially like having a mini formula for the y values. Okay, now, you might be like, do I need to do that? No, because in reality, you know how to triple and add 1. But when it comes to x's, you're going to want it. So, that leads us then to just rattling off some characteristics, because I want you to see how much you really do already know. If I said, hey, what's a domain, you're still going to tell me what? Okay, you now can tell me the range. What is it? What's the range?
-2 to 4.
Which means I know the min,
-2.
and I know the max.
4.
Okay, you with me so far?
Yeah.
Yeah.
Okay, now watch, again, there's only a few things I don't know. What's the amplitude?
3.
Vertical shift.
1.
Okay, watch this. Don't I know the phase shift also? It is. Why is it 0? Because you're not what?
You're not adding.
You're not adding or subtracting. So bottom line, we're down to one thing that we don't know. Now, this is where it gets dicey and you got to pay attention. Dicey. The deal is that what my equation will typically give me that I can see is what I would typically refer to as the period adjustment. Now, some people, especially when you get into college, they're going to call it just your horizontal scale change. They might just call it your B value. I think that's silly to memorize random letters. So we're going to call it our period adjustment. Now, that is literally the number attached to the x. What is that? 1/2. But to find the new period of that cosine, there is a rule that says I take 2 pi, I divide by my period adjustment, which will give me 4 pi. Okay. Now, if you are totally with me so far, just raise your hand. Did I lose anybody? Okay. So, now, everyone agrees there's no phase shift, right?
Yes.
So 0 has gone nowhere. But, how far, watch this right here, how far will pass on the graph to go from the 4 at the top to the 4 at the next top? Twice as much. How much? 4 what? Pi, right? If my period is 4 pi, that's how long it takes to go from my maximum of cosine through my maximum again. Because before, it was 2 pi. Well, now it's 4 pi. So what am I going to put right here? Okay. Cut it in half. What's this? 2 pi. Don't you cut in half and then do what? Cut in half again. What's between 0 and 2 pi? Pi. What's between 2 pi and 4 pi? 3 pi. Okay. Now you need to watch because I'm gonna keep cranking, and you're gonna stop me if you need me to, but otherwise I'm gonna keep going. When I go to graph this, it is as straightforward as it might seem. So I go 0, 4 pi, cut in half, half, half. I can go back the other way, half, half, half. This graph goes up as high as 4, which is here. It goes pi 1, 2 pi, -2, 3 pi 1, 4 pi 4. There's my graph. It starts high. So going back the other way, if I was high, what was my next one? Now I'm middle, then low, then middle, then high. There's the rest of my full 2 periods. Okay, but if you know you're going to need a technique to finding those x values, raise your hand. Okay, so this is the technique, but I'm telling you, most of you are going to need this for the hardest one, so I recommend writing it down. using this mapping notation, the deal is, notice, we didn't take, if I listed these, watch, 0, pi over 2, pi, 3 pi over 2, and 2 pi. If I listed the parent points, look really closely, don't try to write right now. To go from 0 to 0, you can't tell anything, but to go from pi over 2 to pi, pi to 2 pi, 3 pi over 2 to 3 pi, 2 pi to 4 pi, what are you noticing? Okay, here's why. What I'm really doing, and this is what the mapping tells me, is exactly what happens to all my x values. Okay? But how would you know that? Well, what you're going to do is a process that most of you will like. You take what's in the parentheses, and we know that what we see in the parentheses is the opposite of what happens on the graph. Everyone agree? What you see is the what of the graph?
Opposite.
Opposite. So fine. You know how you can get opposite? Set it equal to a dummy variable. You can pick any letter. Solve for x. What do you get? 2. You double. So when I put it up in here, that tells me what's happening to all my x values. Now, some people are probably like, why would I need to do that? Because I can just see, I was dividing by 2, so I do the opposite, so I'm times by 2. If you agree with that, raise your hand. Okay, here's the catch, though. Here's your second equation. This time, we're not going to deal with anything vertically. We're just going to say, hey, I'm going to take 2x minus pi. But now what's the difference? Yeah, so we're going to need to divide the x values by 2, and it looks like, now listen, it looks like your phase shift is what? Or pi, right? Because it's the opposite of what you see. But you can't do it that way. It's opposite of what you see, and what you see, listen, is multiply and then subtract. Well, how do you undo that? You add and then divide. You got to go the reverse. So the best way to find this out, take what's there. Set it equal to a, what did I say? A dummy variable. Solve for x. How would you solve for x? Add pi, divide by 2. Now watch what happens. This then shows you not only what's happening to your period, because someone said, oh, you just divide it by 2, right? Who saw that? Okay? But this pi over 2 is actually your phase shift. Now, some of this won't totally sink in until Monday. But if you write this down, you can at least have it as a reference to try. Okay? Okay, so what does this mean for our points? Has there been any vertical effect whatsoever? Okay, so where does sine start? In the
0.
middle at 0, then it goes
Up.
up, middle, high,
Middle.
then, okay. But now,
That's not right.
Wouldn't it be 0, not 1?
oh, sorry, 0. Thank you. But now, that's what you meant, right?
Yeah.
Now, I am taking my parent points. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And my mapping tells me that I cut them in half and add pi over 2. So take 0. Cut it in half, it's just what?
Why are you adding pi over 2 instead of pi?
Because you gotta, it's only until you undo all the operations in the proper order that you get the phase shift. Okay, take 0 times the half, you get
0.
plus pi over 2, you get.
Pi over 2.
Now watch this, because this is probably the best part that makes it a little easier. I know it doesn't make it easier now. Take pi over 2. What's pi over 2 times a half? Pi over 4. Plus pi over 2 is how many pi over 4s?
2 pi over 4.
Okay, so don't you agree this is pi over 4 plus 2 pi over 4? That gives me 3 pi over 4. Now watch, this is not a coincidence. How many pi over 4 is pi over 2? How many pi over 4 is this pi over 2? 2 pi over 4. So I got 2 pi over 4, 3 pi over 4. Guess what the next one's going to be? Check it. Take pi. What's 1/2 times pi? Pi over 2 plus pi over 2 is 2 pi over 2. 2 pi over 2 is pi, but how many pi over 4s is that? So you could write 3 pi over 4, 4 pi over 4. What's the next one? 5 pi over 4 and 6 pi over 4. Now we haven't plotted a thing, but we have ordered pairs. Now, I'm going to go all the way up to 305, so don't move, because then I think I can get you out of here on time. But I want you to notice something. If I were to have said from the very beginning, what is the domain, you would have told me what? You would have told me the range is what? With a, I'm not going to write this. Minimum of what? Maximum of what? Okay. The original amplitude stays the same. Still what? Was there a vertical shift?
No.
None. But was there a phase shift? Yes. What is it? Yeah, pi over 2. Now, wouldn't you have told me that the period